With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. In this problem, it is saying that a string has a linear mass density mu. The end of the string are joined to form a closed loop and is given the shape of circular ring of radius r. This ring is now rotated about its axis with an angular velocity omega, and the question is asking that the velocity of the transverse wave set up in the string with respect to the string is. So we have to calculate the velocity of the transverse wave that is producing within the string. So first of all, let us draw. Let's say this is a ring and it has, let's say its radius is capital R. Okay, and this ring is rotating about its axis like this way. So here this what we have. Now due to this rotation, here it is moving about this axis with angular velocity omega, and here radius is r is given, and here mass density per unit length that is given, and this can be written as total mass upon 2 pi r. So that what we have here, and due to this rotation the tension will be developed here. Now to solve this problem here, let us first of all let us calculate here. Let's take here a small segment of string. So here I'm taking here a small segment of string. So here let us draw. I'm taking here a small segment of string like this. Okay, so this is our string and it has uh, radius like this. So this is our actual situation here. Okay, and it has total angle, that is d theta. So this is the total angle here, and radius is r is given. So basically its total length will be here. We can write here that its total length that will be here r d theta. So we can easily calculate the mass of this. So here the tension developed, let's take up here any point. Let's take this is a point just like a bisector. So we will have the situation like this. So this will be like okay, so this is our situation here, and here due to this tension would be like this way. Here tension will be act like this way. This will be, let me draw first here. So this will be the direction of tension. Let us draw here this also in a big manner. So this is tension would be like this. So tension will be like this way, and due to this tension will have, since this is bisector of this, so this angle will be also d theta by 2. I'm sorry, this is d theta by 2. Let me write here. This angle is here d theta by 2. Okay, so this angle is d theta by 2. Similarly this angle is here also d theta by 2. That what we have here, and due to this tension will have two component here. This tension will be divided into two components like this way here along this direction. Since this is angle theta d theta by 2, so this angle will be here also d theta by 2 by alternative uh, rule. This angle will be also d theta by 2. Okay, so this is our angle d theta by 2. Now along this and toward this direction tension will have component. So basically we have resolved this vector of two tension component along this line or this line. So the centripetal force will be here vertical downward direction of vertical downward component of tension which is acting toward the center, that will be provide the essential centripetal force to rotate the spring in a circular manner. So here let me write one by one. So this will be here T cos of d theta by 2. Similarly, this component will be also here T cos of d theta by 2, and toward this direction here we have uh, T 2t sine d theta by 2. So here one thing I would like to write here, that here 2t sine d theta by 2 will provide here Fc. So by this analogy, so Fc will be equal to mv square. Sorry, here more precisely I would like to write here, I must write here dm v square, because we have taken here a small m segment. So this will be m v dm square by r, and this Fc here, that is tension, that is 2t sine d theta by 2. So from here this will be dm, and this dm we can write, that is mu r d theta, and this velocity can be written as here, that is omega r its square over r. So from this analogy we can also write, since d theta is very small, this is, let's say this is equation our first, very small, thus sine d theta by 2 will be approximately equal to d theta by 2. So this is our equation 2. Now from, we can write here that from equation first and second. So from these two equation, when we put their corresponding value here, this will be here d theta by 2, and on the right hand side I have here r d theta, and this r will get cancelled out. Here I will have only omega square r, so this d theta will also get cancelled out. So from here tension, I have this 2 will get also cancelled out. So I have here tension here, that is mu r square omega square. This is our equation first. Now finally, since v in string, that is transverse wave velocity, can be written as, this is transverse, can be written as, that is t by mu. So this vt can be written as, that is velocity in at string, that can be written as here tension is our mu r square omega square, and here this is mu, this will get cancelled out. So finally we will have vt is equals to r omega. So this is our final answer, that we need, that what we have to calculate here. So if we look at the option, our option number first will be correct answer of this given problem. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.